what are the equations of motion? The very first one is coming from where? The fact that acceleration is still in velocity with time. Okay? So what is change in velocity? Final velocity line of what? Initial velocity over time. Good afternoon. And good evening, depending on when you are watching the video. As you can see, we're in the live class. And some students are already in the class seated. So we want to just record an aspect of the entire lecture, okay? So this aspect is the equation of motion. So this is under motion, and we have tried to explain some parameters that are used in calculation related to motions. So these calculations, we have some terms that are commonly used. All right. Those terms include number one, the position, the distance, displacement, acceleration, right? Speed, velocity, and what? And deceleration. Okay. When it comes to equation of motion, there are four equations of motion. There are what? Four what? Equations of motion. But you must understand that apart from having four equations of motion, these equations of motion are only applied for uniform acceleration, please. The equations of motion are only applied for what? Uniform acceleration. Uniform acceleration simply means, when you have a motion starting with a particular velocity and what? Ending with a particular velocity. Either zero or non-zero velocity. What I mean is that the uniform acceleration is that a motion starts from there, let's say from point A, and move down to point B. That is uniform acceleration. It doesn't mean that the thing stops moving, right? It will move from B to C, but it is a different acceleration, not the same with this one. So for you to apply equation of motion, you must only apply that equation for what? From A to B. Alright? So something starts from rest. Let's say something starts from rest. Starting from rest means that the velocity is zero. And you accelerated along the particular distance forward. Let's say I'm attaining the velocity of 20 meters per second for 5 seconds. If anything like that is possible. So it accelerated. So it still moves from point B to C, identically, with a constant, let's say with the same velocity, right? Or another different velocity. Identically, for another 2 seconds. Identically. So this is constant, it means that the velocity is also 20 meters per second. Please, the equation of motion that I will use here is not applied from A to B altogether. The only way you can apply it is from A to B, do your calculation, then from B to C, do your calculation. Alright? So the best way is to have what we call what do you call it? Motion graph. Either your velocity time graph or your displacement time graph. So what are the equations of motion? The very first one is coming from where? The fact that acceleration is still in velocity with time. Okay? So what is change in velocity? Final velocity line of what? Initial velocity over time. Identically, when you come to time, what do you have? AP equal to what? B minus U. Identically, that ends up what? This implies that what? When you make this one solve the formula, it means that V, this one will move to the other side as you may have it. So we have what? V is equal to U plus AP. This is the first equation amongst many others. This is the first equation, but it's coming from what? The fact that acceleration is what? Change in velocity with time. Do you understand that? Remember, these equations are only applied for what? Uniform acceleration. Let's write the other equations then. I will now give you some other guidance. So the other equations include what? S equal to UT, right? Plus or minus 1 over 2 AP squared. right? Plus or minus. Then what? H or sorry, confused. V square equal to what? U square plus or minus what? A what? S. Sorry, 2AS, I mean. 2AS. Right? 2AS. So the other one, this is what S equal to U plus V over 2 times P. This is for what? Average velocity. This is for what? Average of velocity. Are you okay now? Can you see what on the board?
Yes, sir.
Okay. Now, the point I want to make now is this equation of motion, number one, it has plus and minus. The plus is for when you are accelerating, while the minus is for what? Deceleration. So accelerating means that the velocity is increasing, maybe starting from 0 and get to another higher number than the initial one. I get you now. That's why we have final velocity and initial velocity. But deceleration simply means what? The velocity is at a level and is coming to a lower one. That is 0. That means of deceleration. That means of what? Deceleration. So when you are calculating for deceleration, you are expected to use minus. But when you are accelerating, you are expected to use what? Plus. That is why you are saying that each of the equations have what? Plus or minus. It's a very simple thing. Do you understand me? The other point include the fact that when you take something start from run, it means that the initial velocity is 0. Velocity is what? 0. But if the now say is going to rest, what does it mean? The final velocity is what? 0 when it's coming to rest. So what you have these two values, your calculation will be very easy. Let's start. So oh, it's not funny. Let's start.